You're gonna pause it and put the two functions in to y1 and y2. Put in f and g. Okay, so welcome back. I want to make a note. You don't have to put those in for y1 and y2 because these derivatives are easy enough. You might want to just do their derivatives by hand. So if I take the derivative of f, 3 comes along for the ride. E is just an exponential, so I recopy the base and the exponent. That's its derivative. Times ln of the base, which really is just 1, so I don't show it when it's e. And then for chain rule, the inner function was 2x, so it's times 2. So that derivative is 6e to the 2x. So you could just work straight off of that and plug 6e to the 2x in, because what we're going to do is some work with the derivatives. But I want to show you how you can do it on the calculator as well, so you don't have to do the derivative. Of course, g of x is easy enough to do. The derivative of g prime is easy enough to do. It's 18x squared. So I could use these two functions and just work the calculator from there. But if you want to see how you can use the calculator to even do the derivative part here, I'm going to do that. So I put in my two original functions, f and g, into y1 and y2. y3, I'm going to make be the derivative. It's going to graph the derivative of f. It's going to be f prime of x. So I'm going to do my n derive here, which is the derivative. It's with respect to x. I'm going to be taking the derivative of the function y1. And I'm not going to put in a number. I'm going to say that it's for all x. So this now, this function y3, that's my derivative of y1. Okay, and we're going to want to look at that graph in a second. So I'm going to turn off y1 because I don't want to see the graph of the original. I just want to see the graph of the derivative. We're going to do the same thing for g now. We want to find the derivative of g and look at its graph. So I'm going to do n derive for my second function. So it's going to be y2. And that's going to be for all x values because I want the function. And I'm going to go turn off my function for y2 so I don't look at the graph. So now I have the derivative of f and the derivative of g in for y3 and y4. Let's look at the question. So the question says, at what value of x do the graphs f and g have parallel tangents? Well, parallel tangent lines means if they're parallel, their slopes are the same. Okay, and if we're talking about tangent lines, we're talking about derivative because slope of the tangent line is the derivative. So the derivatives are the same. So at what x value are those derivatives the same? That's why we can just go ahead and graph. I'm going to zoom 6 to go to my standard window. We can graph our two derivatives. We want to see for what values of x are they the same. So we want to find the intersect of our derivatives. That's where the slopes would be the same, where they have the equal derivative. So the first curve is the black curve. Second curve is the pink curve. They want to guess. I'll move the thing over a little bit, right about there. And they're coming up with, it's a little hard for me to see here, but negative 0.3906, which rounds up to choice C.